Very good. I have a, yeah. So, and then everybody, are you guys ready for chapter A?
Oh, yeah.
Yeah. Say yeah. Woo. Why not? The class don't have to be boring, right? Right. Again, this is more your mindset, right? Okay. So now we are getting into the real stuff now, right? We work so hard. The purpose is to do the hypothesis test. Hypothesis test, okay? So why we need to do hypothesis test?
Because you need to figure out if your theory is right or not.
Yeah, to figure out if your theory is right or not. And of course, you need to get data to figure out. Data to figure out. So we done so far G. Okay, so actually G will be one of them you can use to do your hypothesis test. But this chapter mainly is to walk you through the step. Walk you the step. How do we do hypothesis test? Okay. Okay, so when we say hypothesis test, okay, sorry, it's supposed to be used, not sued. Okay. Let me change it here. So used. Okay. So hypothesis is the procedure used in inferential statistics to estimate population parameter based on a sample data. Okay? So that's called hypothesis test. Okay, so this is the question. Okay, we are going to use many. We're going to use some numbers. So when we do the step, we need to have a number to base on. Okay, so this is just the sample question actually from the book. Okay, so they say they do the standardized test, right? In fourth grader, their normal distribution for reading is mu 70, right? And then they are doing random select a sample and do this test and find that M is 75, okay? And so if you look at this, from your chapter 7, you pretty much know how to get your Z-score, right? Mm-hmm. So easy. We can just get there, right? But the purpose for this chapter not only ask you to do Z-score. We use Z-score to test our hypothesis. We'll use Z-score to test our hypothesis. Okay, so now with this number in mind, let's move on. Okay, so when you do hypothesis, okay, now, when you do your homework, Andrea said it's very easy, only 4 questions. But even just 4 questions, I would expect you to follow the step, and step. Okay, I found a lot of times students after when they do this hypothesis test, they forget to give me hypothesis. You they just so get into calculation. Then when they finish, I say, what's your hypothesis? If you don't make any hypothesis, what are you testing for? I don't even have no idea. Okay, so when we do the step, okay, the first step is you formulate hypothesis. You formulate hypothesis. Okay, so when you formulate hypothesis, okay, so this is just the step. We just go through them, and we are going to go each of them. Okay, so no, they are the same here. Don't worry. They're just the step 1, step 2, step 2, step 4. I know you want to write, but actually that's same here. Okay, so when you are formulate your test, okay, formulate your hypothesis. Okay, I said part 1 below is several parts there. Okay, now you have 2 hypotheses there. One called HO, one called H1. Okay, now what's HO?
The no.
Non-hypothesis. And non-hypothesis, the words for this is mean no. No. Okay, or you can say, so non-hypothesis actually is the attribute at any difference between this. Okay, mean to chance. Okay, so that means if you are no different and you say they are different, What's that mean? Okay, so then HO can describe a statement of this is rewriting, and then I give it a real one like this. Okay, so what we are doing this. What we are doing this. Okay, we say, well, they are no different. If they are different, that's just by chance alone. It's not even count. You know what I mean? So sometimes you can just say no different, no true different. No true different. And even you say, yeah, there's some different, it's due to chance. We due to the error, so it's not count. Okay? Or we say that's not effective, ineffective. Okay, so here, if you see this, the key is they say equal. Okay, remember our simple equation is your mean score from population is 70. And we are testing, see if our fourth grader is better than the population. No, and then when we do non-hypothesis, say, no, they should be the same. Okay, and why we say 70? Because that's the mean from population. That's why I show the number. So when you are doing your hypothesis, write down the number from mu. Okay, based on mu, the number I give to you, write down into your hypothesis. Okay, so now you know that 70 is not the standardized word. That's just a number we use for this example. Okay, everybody? Okay, so that's non-hypothesis. Pretty much you say the same or no. Right? So, for example, when you want to make friend with somebody say, that person looks so nice. Maybe I want to make friend with that person. Okay, your non-hypothesis will be, she will not want to be my friend. She will not. So with this mentality, you go and you're less likely to disappoint it. Right? So you just think worse. Okay, so that's your non-hypothesis. But is that really the main purpose of your research? You really want to work so hard and say they are no different? No, that's not your main purpose. Actually, your main purpose is under your research hypothesis. Your H1. So your H1 is the object from your HO. Okay, and this is what you really want. Okay, and so when we describe H1, they have to be directly object from your HO. Okay, so if your HO say no different, then here you say different. If your HO say ineffective, then you have to say effective. Okay, if your HO say equal 70, here you have to say unequal to 70. Okay, have to, because there are so many different ways you can write, but make sure you write exactly object.
Can you say that it's not by chance at that point too?
Yeah, but then don't use the words yet. It's a little bit more complex. Okay, so you can say so here actually this over there say what? Not true, right? No true difference there, right? So here you want to test are they true difference rather than just by chance. Okay, rather just by chance different. They are real. Okay, effective. There say ineffective. Here you want to see if they are effective. Okay. Oh, so the symbolic for this one will be unequal. Okay, and then later I'm going to tell you about, remember I talked about one tail, two tail, right? So if you say one tail, you can be greater or less than. But if you do two tail, it will be equal, unequal. Equal, unequal, it means I just tell you they are different or not different. I didn't tell you which one is better than which one. Okay. Ideally, when you do your research, you more likely use two tail. don't to assume that they have to be one direction or the other. How do you know? So in general, in the research field, we use two tail more than one tail. But then, when you do your homework, you need to look at what do I ask you? Do I ask you one tail or do I ask you two tail? Okay? Okay. Now here actually two tail, one tail. Okay. So two tail is no direction. And actually, I kind of steal this from next chapter. I feel I should tell you this early, so I steal this part from the next chapter. Okay. So two tail. Okay. So two tail is the one we talk about, and then we are going to talk about one tail. So two tail is HO is equal, right? For the value they give to you. Okay. And then this will be H1. Okay. So then in our class, for statistics class, you can just use symbol. Okay, I don't need you to write the whole sentence. You can just give me the symbol. Okay, so that's your two tail, equal, unequal. And then also, I sometimes find students make mistake. They reverse this. They put HO is unequal, and H1 is equal. Okay, make sure. Tell yourself HO is no, and no is mean equal. Okay? Okay, so now it's one tail. Okay, so I tried to write one tail, but okay, sorry. I think I tried to put one tail. I don't know. Okay, so for one tail, then you have to figure out, are they left side or are they right side? Okay, you want to, if you are doing one tail test, you want to know, are you testing this side or are you test that side? Okay, so if you are test left side, then you have to, the one you don't like, the one you want should be research hypothesis. Right? If you are testing left side, that means you assume they are less.
Literally pointing that way.
Yeah, because you assume they are smaller. So then write that first, and then write this one, because this one will be object. I think it's hard to think HO or be confused. So I will encourage you to write H1 first. So H1 is the one you want that. That's your main purpose of research. Okay. And this one no equal sign. No equal sign, just less. Okay, just less. Then your HO have to be object, right? So who take care of equal? Well, that HO take care of equal. Okay, so HO will be greater. HO will be this side, the body. Okay. And then your real research is tail. Okay, everybody clear here?
Mm-hmm.
Then how about if you are testing right side, then your research hypothesis will be greater. Because you want to test in this one, greater. Right? And then your HO will be less and equal. Okay, make sure, because this is also very important. When you do your homework, if this part is, because when you do your homework from the research question, you can kind of tell which direction. Okay, for example, if they say less is better, they want to be smaller. Like when you try to lose weight, you want to be smaller, right? Then they maybe tend to be this. If you try to gain weight, then you may want to this one. That makes sense? Okay? So this is one tail. So one tail, the way you write a little bit, need more thinking than two tail. Two tail is just equal and equal, that's it. But then one tail, you need to say, then which side? Which one my preference? Right? For example, you say, when people learn the statistics, we assume they have anxiety, so their level will be higher, right? They will be higher, right? And then so your class, you want them to reduce their anxiety. You want them to, so you say my class will help them reduce. So you want them to be more, go to the left side. Okay? That's good. So this is just a concept. And then I steal this chart from the next chapter. So if you look at the book, you don't find this chart, that's in the next chapter. Okay? I just found that very useful. I should talk about here. Okay, and then make sure that I will change that, but it's mistake there. Okay, so we finished the first step. What's first step? What do we do first step?
Formulate a hypothesis.
Formulate hypothesis. How many hypotheses you have? You need to do? Two. One's HO, one's H1. Make sure you have this step there. Okay. When you do homework, just do step by step. Okay. You really want to do calculation, but start doing your hypothesis first. Okay. The next step is you have to find the alpha level. Okay. Alpha level, actually the one we just learned, those G-score. The G-score. Okay. So now, from now on, you are going to have a 2 G-score. Okay, let me tell you before we get there. Okay. In this step, when you get G-score, it's called G critical. In step 2, you are going to find the G-score, and then actually it's called G critical. And then when you go to next step, you are going to calculate, and you will find the G obtained. Okay? So if you find from the table, we call G critical. If you calculate, got from yourself, it's called G obtained. Okay, so you have a 2 G-score. So make sure when you are writing, you put G critical in the step 2. Okay, so what do we do that? Okay, so the alpha level is the probability level set by the researcher that different point at which HO should be rejected. Okay, so for example, if we say my alpha level is 0.05. If my alpha level is 0.05, okay. So the alpha level 0.05, actually that's the we so-called in our table called probability. Okay, that will be in your tail, and you find a 0.05. Okay, and then if you are 0.01, that means your tail, you find a 0.01. If you are one tail, okay, if you are 2 tail, you have to divide. Okay, but what's that really mean? It's easy just say it. It's significant level, but what's that mean? Okay, here say the critical region is the area of sample distribution in which score outcomes are highly unlikely to be there. Okay, so if they can be there, then that means they are so good. Okay, so you say, okay, I'm putting 0.05, and then if I divide them, will be 0.025, right? And I say, I set up here because people less likely to get here. Okay, so for example, I say, for the student taking the statistics class, okay, less likely they will reduce their statistic anxiety. If they can get there, that means they are so good, reduce enough statistic anxiety. Okay, so you say here, actually you want your number go there, but you know unlikely. You know unlikely. Okay, so this is your cutting point. Okay, so if you remember, you say your hypothesis, right? And you say mu equals 70 and mu unequals 70, right? Right? When you are getting your number after you calculate your G-score and they are greater than your G critical, they are bigger than your G critical, they are come here, or they are less than the number, okay? They are so great that you will say, no, they are not the same anymore. If they are over the number you set up, it's, oh my God, so good. So you say, no, so this is not true anymore. Everybody follow me? Everybody? So quiet, I don't know what that means.
My brain's hurt.
So you put a cutting point. Say you had to perform so well over this point, then I will assume you really different. Otherwise, you just so. You just like everybody else. You have to be so outstanding. Over 95% of this middle range. Okay, and actually you can also say, because score in this area, if your score can follow in this area, they are unlikely to be by chance alone. They must be real. You know, because by chance alone you can get a very good grade in one test, but maybe not overall. So you get so good, you jump over there and say, wow, it's real. Okay? So that's also mean that. Okay? Now, here say, this also area to say, in here, did you see the words here? Non-rejection and rejection. Okay, so if your number just so, your performance just so, then I just assume you are same as everybody else. So I'm not reject any my non-hypothesis. So for example, you want to go to a restaurant for lunch, and then your friends say, the restaurant food so good, you love it. So you have a hypothesis there. One will be, well, so, and one be yes, right? So when you finish eating and you come back to class, your friends say, so, what? You say, it's not as good as you say, it's so. So then you just accept the non-hypothesis, no different. But you say, wow, it's so good. Then you reject your hypothesis, yes, they are very different. They're outstanding. Okay, so this is the setting you have to decide. Okay, if you just look at this, which one more likely to reject? 0.05 or 0.01? Which one more likely to reject? Which one the door actually wider, bigger, more likely to reject? 0.05. See, this big. If I shrink to the 0.01, it'll be this one. So small, very hard to reject. And also, if you think about the regular language, you can say, actually, I assume 5 out of my 100 chance can be just by chance alone. Can be mistake 5 times. Because I make a door open wider, so that means if I run 100 times this research and then 5 times, actually, it's really just by chance alone. It's okay. But then if I put 0.01, that means only one error allowed. Okay, so for example, covariance. You go to test positive and negative, right? How many chances you allow them to make mistake? You really test our 100 students and then 5 of them test positive, but actually they are not really positive. Right? Or you say, no, you only allow 1 chance. Or you say, no, not at all, then you will set 0.000. That means whatever you say have to be accurate, not by chance alone. Usually in our field, social science, we don't kill people, right? So 0.05 is okay. We pretty much do 0.05. But if you are medical field, all that you don't want to take medication and they say maybe 5 out of 100 can be error, right? You don't want that, right? Okay, so clear about alpha level and what we need to set up this. Everybody, tell me. Ready to move on? Because this is very important. And actually, when you do your calculator, this is most easy one. You just say alpha equal 0.05 because I told you. But I want you to have an idea of what that means. Okay, so once you set 0.05, then the second part of step 2, you need to determine your critical value. That means you go to table 1, find your Z-score. Okay, you go to table 1, find your Z-score. So if we say 0.05, right? So when you say okay 0.05, that's one of your steps. For 2 tail, then you will have a 0.05 divided by 2, you get 0.025. Why divide by 2? Because 2 tail, right? And then so you just go to your table, C column, and find your 0.025, right? And then find the Z-score. And we found it before, right? So you find it is 1.96. So, and then negative 1.96. Okay, so then in this step, you will say, remember this time you will say Z. So you will say Z critical, and then make sure you tell me it's positive and negative. Okay, so you say positive, negative 1.96. And that word, that positive, negative, very important, okay? If you didn't write that, then you get a point off. You can either say positive 196 and negative, or you can write them together. If you are typing under the symbol, you can find the positive, negative. You just insert. Okay? So then that's your list step. Okay? Let me put here, it's here. Okay? Okay, so what do we do first step? Let's review one more time. What do we do first step? Hypothesis. So you say non-hypothesis and research hypothesis. And then you go to second step. And you set your alpha level. And then find your critical value. Okay, so that you do this before you get into calculation. Don't do any calculation, because once you get in calculation, you will more likely forget about first 2 steps. Knowing the first 2 steps also earning the point for you. They are as important as other steps. Okay, because for this chapter I count by the step. Okay, because as a researcher you need to follow that. Okay? So then the third step, okay, so we have this. Okay, now let's go to 1 tail. Okay, let's go to 1 tail. Okay, remember we say 1 tail, you either less or greater, right? So if this is 1 tail, okay, also important to remember. If you are testing greater for your research hypothesis, if you are testing greater, your Z have to be positive. Okay? If you are testing greater, that means you are testing, you think more is better. You want your student improve, do your treatment or do your teaching. Okay? And then they'll be testing hypothesis for 1 tail, and they'll be in the right side. And so the G critical you give to me have to be positive. And you don't have to divide by 2. So if I say 0.05, that's 0.05. You don't divide by 2, that's important to be aware, okay? You don't divide by 2, so you are looking for your tail under 0.05. Okay, and then you give me positive number. Okay, good? Everybody good? Okay, so, another hand, if you are testing less, then you will be in your left hand side, okay? And again, don't divide by 2. Don't divide by 2, whatever the level I give to you, okay? And then you need to get G critical have to be negative. Okay? It's very important to be aware. Okay. Are we good? Before we go to next step. Okay? So, then you finish these 2 steps. Okay? Then you go to your step 3. Then this one is easy. This one, the one we cover the whole chapter, right? So, but only I want you to be aware, make sure you write obtain. So when you are giving G critical, you write G critical. And then this time you write G obtain. So then you don't confuse yourself. You know, after you finish your calculation, and so what's this, right? So G obtain and everything is the same, okay? So for our example, okay, then you have a 10 standard deviation, and you have 25 people. Okay, so you got your standard error is 2. Okay, then you got your G of 10 is 2.5. Okay, so now we have to get to decision. Okay, but make sure you know this. Okay, everybody good here? So step 3 is easy. Right, step 3 is easy, right, you got this. So 2.5. Okay, so now you have to think about what's this mean? Okay, so you go back to your hypothesis, okay, and you say, I set up 0.05, and then so my critical, G critical is positive and negative 1.96. Now I got a 2.5. Now I got a 2.5. So where is 2.5? It's better than 1.96 or worse?
Bigger.
Bigger. So it's here, right? Here. Okay. So it's here, big. They are jump to this side. So how do we make decision? So this is mean the score is better than what you expect. Okay, so if the result is better than what you expect, then original we say this. Is this still true? Original we say so. But then you surprise your superintendent because your G score is bigger, it's already get into rejection area. So that means this is no longer true. So then we will say reject. We will say reject. Okay, so since G of 10, 2.5, which fall in rejection area, so we reject. Okay, we reject. Okay, you reject HO, And what's that mean? Remember, you have this. So if you reject this, then that means this is true. But we don't just say H1 is true. We say we reject this. Okay? Statistical area is more conservative. They would rather tell you reject and then for you to believe it's true. They don't just go say it's true. Okay? So they are more conservative. Okay. Is that good? Is that good, everybody? Is it clear? What are we doing? Okay. So then here, that is important language here. So if that's true, you need to tell me. So if this is a P probability, you need to say your P is smaller than the one you set up, 0.05. Even we divide into two sides, we still use 0.05. Okay, and then I find sometimes students want to tell me equal something, equal to the area you find that, okay? You don't need to use equal, just say less. And then if they are fail to reject, your number falling into non-rejection area, then here will be P greater than 0.05, but here will be P less than 0.05. If you are failed to reject, okay, you'll say, okay, P greater than 0.1 is failed to reject. If you are P less than 0.05, that means yes, reject. Okay? Good? Okay, so now, to make them even more accurate, okay, usually we will follow another step called effective size. Okay, so that means we say we reject. So that means you are testing your reading program and you say, yes, my reading program is effective in my school district because it's better than the population mean. Okay, but is that really your program? Is your program really that good? You say, yeah, I got a rejection. Yeah, so what? Okay, so you want to persuade your superintendent even more, then you do effect size test. That means I'm going to test, is my program how effective? I know it's better than population, but how effective? Okay, so now we are going to calculate something called Cohen's d. Okay, so the formula here, you need to put a absolute value here. Okay, so D equal absolute value mean minus mu. So that means your number have to be positive. Everybody familiar with the absolute value, right? Whatever number you put inside the parenthesis absolute value, they become positive. Okay? And then also be careful. Here we divide by standard deviation. We don't divide by standard error. Okay. So then for our example here, okay, so you have 75, right? 75 is the mean score you got from your group. Subtract 70 is the one from population. Okay, and divide by standard deviation, so you got a 0.5. Okay, now, what's 0.5 even mean? This chart is important to know. Okay, this chart from your book. So if you got an answer 0.20 to 0.49, then you will say that's small effect. You got a number 0.50 to 0.79, you say moderate effect. You say 0.80 and above is large effect. So then for this one, since they are 0.5, so they are moderate effect. So that means, yeah, my program show the result is better than average of the population, but in terms of program itself, how they effective for their reading ability actually is moderate. It's moderate. By the way, if you didn't reject your non-hypothesis, do you still need to do this? If you fail to reject, that means you already know, you already tell the whole public, my program didn't really different from population. Then you don't need to do this step because it's redundant. Why you need to do this? It's already not good. So then why you need a test effect size? Then you can stop. If the question I give to you, you fail to reject your non-hypothesis because you obtain, G obtain is not get into your rejection area. Then you stop. Okay, everybody? If you do that, if you fail and you do it, then I count you are wrong. Okay, so you say, but I do the work, yeah, but you don't need to do the work. Okay? So this is the hypothesis step. Okay, so let's look at your turn. So this is the real calculation right now. Okay, so let's do our step. So let's see how do we do this one. Okay, so a standardized product scale has U25, standard deviation 5. The CEO of company A wants to know if employee participation in company decision has effect on productivity. A sample of n equals 75 employees who participate in the decision-making process and got m equal 27. Okay, and then here, alpha level 0.1. And do 2 there. Okay. That's your first step. Look at that. That's your first step, right? So you assume equal 25. Where's 25 from? Where's 25 from? From here, right? Make sure you use mu for your hypothesis, okay? Don't use 27. Don't use mean. You use mu because you are testing for population. You are testing for population. Okay, so that's your first step. Okay, then your second step, you put alpha level is 0.01. It's 0.01. Okay, and then since there are 2 tails, so you need to divide by 2. See, so you got a 0.005. Okay, then you go to your table, find your tail for 0.005, then you got critical value is positive negative 2.58. Okay, but so far so good. And you can tell that 2.58, right, from your critical value. And make sure, remember, you have to write positive negative because that's mean both sides. So actually in this one, 2.58 is very important word, okay, important number. So we put the tail there, 2.58 positive negative 2.58. Okay. Okay, then we put the okay. Then let's go to step 3. Okay, so step 3 we calculate. Now you calculate. So you got standard error first, right? And then you got your G of 10. So now you got a 3.45. Are they in rejection area or non-rejection area? 3.45. Are they inside the rejection area or outside? Or are they inside the rejection area or they are outside?
Inside.
Inside. Okay, because the number actually is bigger than this number. Okay? So then, of course, you reject. And also, please, when you write reject, you have to write reject, H-O. If you just say reject, I don't know who you are reject. Are you reject me or you reject other people? Yeah, you reject H1 or you reject H-O. Maybe you know, but then if I don't say it, then I will assume you don't know. Okay? So tell me reject H-O. Okay, and then you will say G equal this number. Okay, of course, it would be better if you can write me of 10. Okay, I forget to put it. G of 10. And then this number, and then also, because this time I use 0.01. So don't write me 0.05. Sometimes you just get used to write 0.05. You know, just become used to. Now, please double check. If I ask for 0.01, then you write 0.01. Okay, the reason I keep reminding you because I really want to give you a good 10 out of 10. For our homework too, I got a 2 student, 10 out of 10. Okay, you should be so proud of yourself. You know, like I said, oh, finally! Because if I keep seeing wrong, I will think my answer may be wrong. You know, I would say, maybe my answer is wrong because everybody wrong here. But then when I see students get 10 out of 10, I say, okay, somebody agree with me, so maybe I'm
those
okay.
2 people are wrong too.
Huh?
Maybe those 2 people are wrong.
Maybe
too.
those 2 and me, we wrong, and then the rest are correct. Okay, so then we do step 5, is effect size, content speed, okay? So this one, you absolute value, so no negative for your effect size, okay? And then you divide by standard deviation, okay? So you got a 0.4, and 0.4, according to the table, is small effect. Why your book is so small? Are they right now small size?
I don't know. Everyone's book is small.
No, is they
The new one.
oh the new
That's why
one.
your pages are always wrong. We have a different book than you.
They never give me the new book. I asked them, they never pay attention to me. So I'm kind of saying, I don't want to spend my money to buy new one. So you are, where did you get it?
I got mine off Amazon.
Okay, so then we are the same, and they are the new one. Yeah, that size is make more sense, but our size is good too, right? Yeah. You can see my book already broken, but then I don't have any more. Okay. Okay. If you are ready, we are going to talk about something I don't really like to talk about, but I have to talk about, called error. But actually, the more I talk about, I find actually it's not that hard. Okay. So we keep saying we are testing hypothesis, testing hypothesis, testing hypothesis. Well, look at this. Okay. We say when we reject, we accept this one. How about if this is true and you reject? Right? Just because you calculate and you say, okay, we reject. How about actually it's true? Right? You went to a restaurant right? And you say, yeah, it's very good. And you reject. Then you go back again and find actually it's not that good. So actually, it's true, right? Or you fail to reject, and it's not true. Now you fail to reject, and that means you assume that's true. Oh, but it's not true at all, right? So that's why we have to, when we talk about this, oh, do I touch something? What do I do? No?
Not always no.
But then why? Okay, thank you. Last time when I recall myself, this board don't work with me, so I have to move to that one. And I pretend I'm talking to you guys. So if you happen to watch the part of section and you feel your Dr. Law is crazy because I pretend you guys are here. Okay. Now the arrow. Good thing I think I'm recording pretty good so far. Okay. So the arrow is we try to be even more careful to see how can we prevent the wrong conclusion. How could we prevent the wrong conclusion? Here say hypothesis testing involves make a decision, right? Either reject or reject non-hypothesis or not reject. Okay. For example, you got a propose from the guy, and then you fail to reject. That means you accept, and you realize something, or you reject because you assume, and then what happened? Okay, so that is a non-hypothesis could really be true, and we could reject, which could be an error. That's one of the errors. They are the true, and we reject, and which can be error. Okay, so just remember when we reject, we say they are no different, right? Right? So let me write down here so we know what are we talking about. Okay, so let's use our example. Okay, so when we reject, that means we accept this one. Right? So that can be one of the errors, right? Or can be we fail to reject, and then actually what? That can be false. You fail to reject, that means you say, oh yes, that's this, but actually it's not true. Right? Okay, so the user language say type 1 and type 2. Okay, so type 1 is what? You reject, and actually that's really true. When we say true, it means this equal is true, but then you say no. Okay, follow me? Okay, follow me, Andrea?
Oh yeah.
Okay, everybody, follow me? Right? So when we are, type 1 error is when we reject, when we say no, but actually they are really equal. This is true, and you say you reject. Okay, that's type 1 error. Okay. Type 2 error is you fail to reject. That means you say, sure, they are equal. But actually this is wrong. Okay, everybody good? You fail to reject, and actually it's wrong. Or you reject, but actually it's true. When we say true or wrong, it's this side, okay? It's this equal and equal. Okay, I'm going to give you some example, and that'll make it easier. Okay, so look at this. We claim the average number of snow days for school in Tiffin is 2.2 days. The average number of snow days is 3.2. So we make a non-hypothesis say, okay, yes, 3.2. And then our research hypothesis says it's not 3.2. Okay, so what is the type 1 error? What type 1 error here? Okay, type 1 error say we reject the average number is 3.2, but actually it's true. Actually, it's really 3.2 days, but in your research you say no. And so then the school district make like 5 days or 10 days because your research show this year the temperature, the weather will be different, won't be 3.2 days. Okay, so they make 10 days or they make 1 day because you say no matter what you do, it's not 3.2. And actually it's really only 3.2. Okay, that's type 1 error. Everybody with me? Okay, and type 2 error is what? You fail to reject, that means, okay, yeah, it's 3.2 days. But actually what? It's not 3.2. So then they come back to complain to you again. You say it's 3.2. Because when we say fail to reject, that means you accept. So they set up 3.2 days. By the end of the day, the end semester, either they didn't use up 3.2 days or they had to use more 3.2 days. Or, because you fail to reject, right? You say 3.2 days. And that's type 2 error. Which one is more serious? Which one we try to avoid? Type 1 or type 2? Huh? Type 1. Type 1. You want to be more conservative, right? But either depend on what's the purpose. Okay, now let me give you another example. The average number of pepperoni on a large pizza is 72. 72. Anybody like to eat pepperoni pizza? Pepperoni is your favorite. No? You are not America. I think America not pepperoni. Okay, so they advertise it. Some people even advertise it, we have 100, right? Okay, so your null hypothesis say yes, 72. So when you order the pizza for your lunch, and your null hypothesis will be say they will be 72, right? And your research hypothesis will be say they are not 72. They are not 72. Okay, so what's your type 1 error before I show? You already kind of get ideas. Can somebody give me the statement for type 1 error? Who want to try? Oh, sure, good. Just hold on a second so I can recall you. You'll be movie star. Okay, say it.
I reject that the average number of pepperoni on a large pizza is 72, even if it's 72.
Okay, so we reject, let's see, reject the average number of pepperoni on a large pizza 72 when it's actually true. Good job. Okay. Okay, who want to try type 2 error? Want to try type 2 error? Want to try? Really? Okay. See, you are Caroline, right? Okay, Caroline, try another one. Yes.
I failed to reject that the average number of pepperoni on a large pizza is 72.
Can you say one more time so we can be sure?
I failed that the average number of pepperoni on a large pizza is 72.
Okay.
When it is 72.
Right? So it's not hard. Right? Actually, before I find these two examples, I kind of like, I don't want to talk about this topic. But once I find some example, I find, okay, now I have something to show my student. It'll be easier. Otherwise, every time when I need to talk about this, I need to call my husband and say, can you give me type 1, type 2 error one more time? And I'll be like, even the people have been teach so long, they can be confused. Okay, so now, let's look at this. If we are using alpha level 0.05, we could lower the probability of making type 1 error by lowering the alpha level to 0.01. Think about this statement and why that's the truth. Right? Look at 0.05. Look at 0.01. Right? If you are applying for graduate school, which one you want them to have? Which one? You want them to have the door open bigger so you can get in. Right? Right? Okay, but the more you reject, the more likely they will type 1 error. Right? So for example, if our school set up the graduate school and 0.05, okay, that means, they reject non-hypothesis, that means they think you are good. So they take you, right? They take you. Then the more likely they may get the student, they are not good, right? But if you are low down your alpha level 0.01, then the non-rejection area is bigger, rejection area is smaller. So you're less likely to reject your non-hypothesis. So the risk will reduce. Right? That makes sense? So if you are the researcher, you want to reduce your risk for type 1 error. You want to set your alpha level smaller. You would rather your research don't get rejection. When we say rejection, means that's good news. Okay, when you do your research, your non-hypothesis get rejected. That's actually good news. Because that means your research hypothesis get support, right? If you worry about type 1 error, okay, for example, for testing coronavirus, right? They would rather be more accurate than you want to put 0.01. Okay? Now let's look at here. Okay, so let's go to our U-turn. Okay, so page 119, okay, say, does the probability of a type 2 error increase or decrease as we move from an alpha level 0.1 to 0.05?
Decrease.
You say decrease? Any other? Okay, so see, I try to put, so I put a line here. Okay, so that's 0.01. So you can see 0.01, that's how much you get rejection. Okay, then the easy understand is inside here, I say that's called type 2 error. Because fail to reject, right? So that's type 2. And then this side called type 1. Okay, so if we move from 0.01 to 0.05, see I have those two lines there. Did you see your type 2 error area is in decrease? Your type 1 error area is increased, right? So the question asks about type 2 error. So is Andrea correct or not? She said decrease. Which area is bigger, now or not? Type 2 error area. It's here or this one? Which one is smaller? This one, right? Right? So actually she's correct. Yay! She's correct, right? You got an idea? Look at what are they asking. They ask for type 2 error. They ask for type 2 error. Okay, so when you change from type 0.01 to 0.05, the area type 2 is decreased, and that means type 1 is increased. Okay, everybody good? We are almost done. We are almost done. Are you ready for the next minute? Okay? Okay, how about this one? This one say if we change from type 1 to type 2, we change from one tail to two tail, sorry. We change from one tail to two tail. Okay, so this, I draw the line, this is for the one tail. So one tail, remember if you are 0.05, your one tail is 0.05. It's bigger. But if I change it to two tail, they divide by 2. And they ask you about the probability of a tail, the type 1 error. Are they increase or decrease? So now everybody look at the type 1 error, this area, okay? Then I'm going to show you another 2 lines. Okay, so now did you see type 1 error in decrease or increase? Decrease, right? Did you see the area shrink? Area shrink, right? Used to be this one. Now I put 2 tail, become this one. Okay, they shrink. Okay, so your type 1 error actually decrease again. And I find that draw the chart is helpful. So if you are confused at home, you can draw the chart to see what's that. Okay. Now, suppose a researcher wants to test a new drug that she believes will promote concentration. However, the drug has some potential dangerous side effect. Would you choose an alpha level equal 0.05 or 0.001 and why? Okay, can I have you and then you can tell us why? Okay.
No.
Yes.
Never answering your questions again.
Now here. Okay, you can answer this way. Okay. Now tell me, what's your answer?
0.001.
Yeah, and why?
Well, because you want to avoid dangerous side effects.
Yeah. So you are less likely to reject, right?
Yep.
If you're less likely to reject, that means you are less likely to risk what? Type what? What kind of error? Type 1 error. Right? That makes sense? That makes sense? Okay. So as a researcher, you can decide what kind of risk you want to avoid. Right? Depend. Actually, you can see they are not perfect. Either type 1 or type 2. They don't have such thing say no error. They don't have such thing say no error. Either type 1 or type 2. And depend on you as a researcher, you decide I want to risk, and I say do not want to have type 1 error, so try to make rejection region smaller. And actually, that's all I have for the thing. Once a lifetime, I can let you finish early.
Once in a lifetime.
Right? Because if we need to do SPSS, usually we take more time.
We all have to study.
Huh?
We all have to study.
I know. Okay, so it's a good thing you have more time to study, right? Okay, so who want to, Chris, conclude our section for us? Say, so this, okay. Chris,
Say what?
say we finished the class.
We finished chapter 7 and chapter 8 today.
Yeah, so everybody have good time? Yeah, say yeah. Okay, great. And then make sure you turn in your homework. Okay, not this homework yet, right? This homework not due yet. But you have another homework due, I believe it's Monday.
Tonight, I think.
Tonight?
I think so.
Tonight? Okay, sorry. I try to give you some more time. Clean your area, yes. Bye.